Hi, this is in place of class time. You're going to be watching this video to catch what I would have covered in class today. First thing, example 1. Adding or subtracting polynomials. We talked a little bit about polynomials were. When you're going to add them, you might be asked a question in this format. One thing I want to make a point is sometimes parentheses have meaning and sometimes they don't. When they don't have meaning, we're free to erase them mentally or physically, and it doesn't change the nature of the problem. So basically, if the parentheses are written and there's not a minus sign right in front of it, that's when it's okay to erase them and it doesn't change the meaning. Likewise, this does not mean multiplication because the two parentheses sets are not bumping right up against each other. They're separated by a plus sign. So it's definitely not multiplication happening here. And finally, if there's no multiplier, a number that's either in front of or behind, that's right up against the parentheses, then it's not multiplying the quantity. So in this case, I'm actually going to say there's no multiplier here and there's no minus sign preceding the parentheses. So this is one of those where ignoring the parentheses doesn't hurt. Same thing here. It doesn't hurt to erase these because there's no minus sign in front and there's no multiplier bumping right up against the parentheses. So really, the problem could have been written just like this. So you would add like terms. 4x squared plus 5x squared is 9x squared. And then you have an x term here, and that's the only x term anywhere. So it doesn't go anywhere, but it has nothing to combine with it. And then we have a positive 2 and a minus 1, and that's just a positive 1. You can't add an x squared term to anything but another x squared term because they wouldn't be like terms. So none of these can be combined. This is your final answer. I'm going to change this problem a little bit. I'm going to put a 2 here. And again, here's another problem, but now we're subtracting one polynomial from another. Order of operations, I should multiply before I subtract. So the first thing I'm going to do is distribute this 2 through. I can't just erase these parentheses because it means 2 times everything. So I'm going to go 2 times a 12x squared, 24x squared. I'm going to go 2 times a negative 3x, and 2 times a 4. And then this minus sign is preceding the set of parentheses, so it has meaning. I can't just erase those either. See, the parentheses go away when you do what it's intended to ask you to do. Here it meant multiply 2 by everything. Once I distributed the 2, the parentheses no longer are visible because I've actually multiplied by 2. Here, I'm going to subtract the x squared. I'm going to subtract also the 5x because I'm supposed to subtract all of this. And I'm supposed to subtract a negative 3. If you recall, the two negatives next to each other changes to a plus. So notice every term within the parentheses flipped around in sign. That's the effect of a negative out in front. You can also put in a 1 here, a negative 1, and distribute it by multiplying, and you get the same 3 terms. Now we've got 24x squared minus 1x squared. That's 23x squared. Then we've got the x terms, minus 6 of them and minus 5 of them is a loss of 6, a loss of 5 is a loss of 11 of them. And 8 and 3 add up to a positive 11. None of these are like terms, so that's my answer. Okay, take a screenshot of that if you want, because I'm about ready to erase it. Okay. You can always drag the progress bar back and take a screenshot if you want. The last thing I'm going to cover today is multiplying. When I have something like x plus 4 times, and most of the time you multiplied by just two other terms, but it doesn't have to be. It can be something like this. The rule for multiplying, even if you've heard that FOIL sometimes can be a helpful memory device, FOIL only works for 2 terms times 2 terms. So the general way to multiply any number of terms by any number of terms is this. Every term in the first quantity gets its turn multiplying every term in the second quantity. So I actually do use my finger. I point to the x, I say x times 2x squared. Remember, this is x to the first, so that becomes 2x to the third power. And then I go negative times positive, 3x times another x. And now I'm going to go x times a 10, which can be written this way. Now, this has multiplied all 3 of those, so now it's time to take the 4 and do the same thing. So 4 times 2x squared is an 8x squared. You can write the 8x squared here. I kind of like to write things with the like terms lined up already, and it doesn't matter. I could have easily written out here. Now the 4 times the negative 3x, negative 12x, and the 4 times the 10. And by stacking them up like that, now I know exactly what terms I have to combine. So going ahead, nothing to combine with this. This becomes a 5x squared. Remember, we've finished the multiplication. It's now time to add. So this is where we say negative 3 of these plus 8 of these same things. So you just add or subtract the coefficients. 10 of these minus 12 of these very same things. And then the 40 has nothing to combine with. And none of these are like terms with each other. So there is your final answer. The one thing I haven't covered is how to multiply 3 quantities together. So if I had an x plus 1, an x plus 3, and an x plus 2, there is a way to multiply those, but I will upload a separate video for that. Your homework tonight will be from section 1.4, 1-4, numbers 2, 5 through 16, all 17 through 51 odd. And you're welcome to start working on those in class. These are all from the online textbook. Okay, so sorry I couldn't be with you today. I have to go have a doctor's appointment with my eye doctor, and I will be back next class. Meantime, I'm sure I'm leaving you in capable hands. Any questions that you have on the 2 sheets that I gave you with radicals, the answers were in the back, but the answer to number 2 on the 1 through 6 problems that you had was written wrong. So that answer is not correct, and I'll probably post later on what the correct answer method is. Okay? So you guys have a good day. Sorry I couldn't be with you, but enjoy this homework that has to do with these things that we've talked about. Thank you very much. Bye-bye.